not. If the property is reduced, it is called as the extensive property, and if the property does not change, then it is called as intensive properties, which is independent of mass. Now, state of system. Now, first definition, what is state of system? A set of properties that completely describe the conditions or characteristics of a system. At a given state, all the properties of a system have fixed values. The state of a system will change when the properties of a system changes. Process, path and cycle. Now, what is process? Any change that a system undergoes from one equilibrium state to another is called a process. Path. The series of a state through which a system passes during a process is called as path. And cycle. What do you mean by cycle? A process with identical end states is called as cycle. Means initial and final position both are same, then the process is called as the cycle. Now, state, path, process and cycle. Let me see compressed process on PV diagram. This is the process. Initial state is 1, final state is 2, and this is called as process path, and this is the piston cylinder arrangement. You can see here this piston moves from position number 1 to position number 2. So, during this movement its volume reduces from V1 to V2, and as the volume reduces its pressure increases from P1 to P2. So, this can be represented on PV diagram like this. Each point along the path is in quasi-equilibrium state, that is assumption, means at every point the thermal equilibrium is maintained, which is practically not possible but for consideration we can assume this equilibrium state. If the process returns to its initial state, then it is called a cycle. Suppose 1 to 2 is the process, and again it goes back to 2 to 1 by some other path, it is called as the cycle. If the outgoing and returning paths are different, means if it goes from 1 to 2 in this direction and if through this path, and if returns to some other path, say from here, some area is covered by this process. So, net work is done and net work is produced. It may be positive or it may be negative. Now, quasi-equilibrium process, a process whereby the system remains infinitesimally close to an equilibrium state at all the times, it is called as quasi-equilibrium process. During a quasi-static or quasi-equilibrium process, the system remains practically in equilibrium at all times. A sufficiently slow process that allows the system to adjust itself internally so that properties in one part of the system do not change any faster than those at other parts. Now, let me see thermodynamic processes, properties and process.
Thermodynamic property and process. The objective of this session is to define thermodynamic property. State the types of property. Define state of the system and define thermodynamic process and cycle. Friends, observe the water boiling in a closed vessel. This is an example of closed system. Before boiling, the water was at room temperature and its volume was 500 ml. Now its temperature is about 100 degrees Celsius. As you can see, the temperature and the volume describe the physical condition of this system. Likewise, every system has certain characteristics by which its physical condition is described. For example, volume, temperature, pressure, mass, etc. Such characteristics are known as properties of the system. Similarly, for a thermodynamic system, any measurable or observable characteristic of the system is called thermodynamic property. Examples of thermodynamic properties are pressure, volume, temperature, internal energy, enthalpy, viscosity, modulus of elasticity, etc. Classification of thermodynamic properties. Thermodynamic properties are classified into two types: intensive property and extensive property. Intensive property. Properties which are independent of total mass in the system are known as intensive properties. For example, pressure, temperature, density, etc. Now consider a bowl of water whose temperature is about 37 degrees Celsius, that is room temperature. If the water is divided and poured into bowls of different sizes, what we find is that the temperature of the water is the same in each bowl. Thus, we can say that temperature is independent of mass. Now let's study extensive property. Properties which are dependent upon total mass in the system are called as extensive properties. For example, volume, energy, surface area, enthalpy, etc. Consider 500 grams of water which can be stored in a container of 500 ml. If the mass of the water is increased up to 2 kilograms, then it will require a container of 2 liters. Thus, we can say that as the mass increases, volume also increases. That is, volume is dependent on mass. Note that when extensive properties are estimated on the basis of unit mass, they result into intensive properties. These properties are known as specific properties. For example, specific heat, specific volume, specific enthalpy, etc. State of the system. The condition of the system described by its properties such as temperature, volume, pressure is called the state of the system. If one or more properties of the system changes due to any operation, then that system has undergone a change of state. Let's see what is thermodynamic process. Process is defined as the transformation of the system from one state to the final state due to change in the pressure, temperature, volume, etc. The various types of thermodynamic processes are isothermal process, isobaric process, isochoric process, and adiabatic process. Isothermal process is a process in which the temperature of the system remains constant. The process in which the pressure of the system remains constant is called as isobaric process. In isochoric process, the volume of the system remains constant. Adiabatic process is a process in which the heat content of the system remains constant. Now we will move on to cyclic process. When a system undergoes a series of changes of states such that the final state is identical to the initial state, then the system is said to have undergone cyclic process. So friends, in this module we define thermodynamic property, its type, state of the system, thermodynamic process and its type, and cyclic process.
So we have seen about thermodynamic properties and processes. Now next term is temperature. What do you mean by temperature? So temperature is a measure of hotness or coldness. The zeroth law of thermodynamics states that two bodies are in thermal equilibrium with the third body, then they are in equilibrium with each other. Basis for validity of temperature measurement is first law of thermodynamics because it states the scale for thermodynamics for temperature. Now what is this zeroth law of thermodynamics? Let we see that.
Law of thermodynamics. Let us understand the concept of thermal equilibrium and the zeroth law of thermodynamics in this session. Thermal equilibrium. The word equilibrium means a state of balance. When we place a cup of hot chocolate in a room, after some time its temperature comes down to the room temperature. This is because both the systems which were in thermal contact have finished exchanging heat. Hence we say that thermal equilibrium has been attained. Zeroth law of thermodynamics. When a body A is in thermal equilibrium with body B, also body A is in thermal equilibrium with body C separately, then we can say that B and C are also in thermal equilibrium with each other. This is because objects in thermal equilibrium have same temperature. In this session, we have learnt about thermal equilibrium and the zeroth law of thermodynamics.
So we have seen the zeroth law of thermodynamics. Now work done on a closed system. What do you mean by work done on a closed system? Let me see one clip for that.
Work done on a closed system. In this session, we will study the derivation of work done on a closed system in quasi-static process. We will also discuss the limitations of work done. First of all, let us study the derivation of work done on a closed system. Consider a piston cylinder containing a certain amount of gas. Now observe that the pressure exerted by the gas is balanced by the weights on the piston to keep the system in equilibrium. If we reduce some amount of weight, then in that case piston will move upwards through small distance dl because of the pressure of the gas. Let P be the pressure exerted by the gas and A be the cross-sectional area of the piston. Therefore, the force exerted on the piston F is equal to P into A. In case of quasi-static process, the work done by the system can be expressed as the assumption for the above expression is that the pressure is uniform. But during this whole process, a system passes through a series of equilibrium states. Observe the given PV diagram. Consider a system travels from initial state of equilibrium 1 to final state 2. The area under the curve, that is 1, 2, 3, 4, represents the work done. Now the equation for work can be written as, note that W equals integration P into dV is valid only for quasi-static and reversible process. Let us see the limitations of P into dV work. The equation for work W equals integration P into dV is valid under the following conditions. 1. If the system is a closed system. 2. When the process is quasi-static, that is frictionless and reversible. 3. When starting and end states of the process are known. 4. When the properties have unique value during the process at all points on process path. 5. Effects of gravity, magnetism, electricity, etc. on the system are not considered. And 6. There is no effect of viscosity on the system. Let us revise the topics covered in this session. We studied the derivation for the work done on a closed system and limitations of P into dV work.
So I hope these videos would be helpful to you to understand the concept of mechanical engineering, various elements